Let's look at part C. I'm going to start going faster with this. Step 1 was to bring everything to the same side. So I have x squared minus 2x plus 1 is less than or equal to 0. Step 2 was to highlight what we're solving for. We are looking for less than 0, so I am looking for my negative sections. Less than 0 below the x-axis. Step 3 was factor. This is my easy factoring since I don't have a number in front of the x squared, so I need to multiply to 1 and add to negative 2. I notice that to multiply to 1 and add to negative 2 would be a negative 1 and a negative 1. That multiplies to positive 1 and adds to negative 2, which would just be x minus 1 squared. Step 4 was to get my x-intercepts. So set my factor equal to 0. I have an x-intercept at 1. Step 5 was to make my sine array. Looks like the only thing I have on this sine array is 1. That's the only x-intercept I've got. Then we would normally come over here and list our x-intercepts to make our number lines. However, this is the first problem where we've had an x-intercept that had multiplicity. This x-intercept at 1 has a multiplicity of 2. Now what that means for your sine array. That means on your sine array, you're going to list this x-intercept. That's what I'm looking for. We're going to list this x-intercept twice because it has a multiplicity of 2. So because it has that multiplicity of 2, we list it twice. So if it was a multiplicity of 3, we would list it 3 times. If it was a multiplicity of 4, we'd list it 4 times. So because this has a multiplicity of 2, it's squared, it gets listed 2 times. So now we do our number lines. This number line has a 0 at 1, so I'm going to put my 0 right there at 1. Left is negative, right is positive. This number line also has a 0 at 1, so I'll put a 0 at 1. Left is negative, right is positive. Look down my columns. A negative and a negative make a positive, and a positive and a positive also make a positive. So if I look at this problem, I was looking for where we are less than or equal to 0. If I look here, there are definitely no spots where I am less than 0. There are no negative parts to this graph. However, there is one spot where I am equal to 0. And that is happening right here at 1. That is where I'm equal to 0. So if I want to list all the places where I'm less than or equal to 0, my only answer would be at 1. And this should make sense if we look at the graph. This graph has an x-intercept at 1, and because it has a multiplicity of 2, that means we're going to bounce off of that x-intercept. So this is what the graph looks like. Notice the whole graph is positive or above the x-axis, and this is the only place where it equals 0. So let's say instead of asking for less than or equal to 0, the problem just asked for less than 0. Then we could say DNE, because this problem, this example, this graph is never less than 0. So let me ask you another one. What if I asked you for greater than or equal to 0? Well, then we could say negative infinity to positive infinity. This entire graph will always be greater than or equal to 0, from negative infinity to positive infinity. Now, here's a tricky one. What if I told you to just find greater than 0, not equal to? If I wanted to list where this graph is greater than 0, this graph is greater than 0 from negative infinity up to 1, but then at 1, it's 0. That's not greater than 0, that is 0. So then I would do union from 1 to infinity. So this graph is greater than 0 everywhere except at 1. So hopefully all of that makes pretty good sense. General ideas: if we have multiplicity, you need to list it that many times and be very careful what you're being asked for. In the last video, we'll come back and we'll try a cubic to put everything we've learned together about sine arrays.